are discussing the arrangement of electrons around the nucleus. The arrangement of electron around the nucleus is the electronic configuration. So electronic configuration is the arrangement of electron in various shells around the nucleus. And I'm giving you a very simple way by which you can make the electronic configuration of different atoms. My method, which I'm going to discuss with you, is depending upon the 3 points. And the point number 1 is having the priority number 1, so that is the period number. So period number tells us the number of shells in the atom. So the atom, which electronic configuration I would like to make, I must first of all look at which period number it belongs to. And this is the priority number 1, to look at the period number of the atom, which electronic configuration we are going to make. Second priority will be given to the group number. The group number tells us the number of electrons in the last shell. And the third priority will be given to the rule 2n square, where n is the shell number. So I may apply it for shell number 1, shell number 2, or shell number 3, that if n is 1, so according to 2n square, if it is shell number 1, so in place of n I can put 1. So it is 2n square, 1 square, because it is shell number 1. So 1 square is 1, 1 into 2 are 2. It means that the first shell can maximum have 2 electrons, which we have already discussed. For shell number 2, so n is 2, so the rule is 2n square. So in place of n I will put 2. So 2 square is 4, and 4 2s are 8. So the second shell, according to 2n square rule, can maximum have 8 electrons. And if it's n3 for the third shell, so in place of n I can place, or I can put 3. So 2n square, 2, 3, because it is a shell number 3. So 3 square, 9, 9 2s are 18. So the third shell can maximum have 18 electrons. But we should not forget that the priority number 1 is the period number, the priority number 2 is the group number, and the 2n square rule is having the last priority. And this is, I am going to apply these 3 points to draw the electronic configuration of various atoms before you. But during drawing the electronic configuration, I shall take care of the period number, the group number, and the 2n square rule. And I should not forget that the first priority will be given to the period number, second priority should be given to the group number, and that last priority, the third priority, will be given to the 2n square rule. So for example, if I would like to draw the electronic configuration of carbon, 6, 12. So you can look at the periodic table. Periodic table will be given to you in the examination hall, and you should consult periodic table. The carbon 6, 12. So we have already discussed to find the number of proton, number of electron, and number of neutrons. So its protons are 6 because the proton number is 6. If protons are 6, electrons must be 6, because protons and electron in the atom are equal, because atom as a whole is a neutral particle. And we know that neutrons, we have discussed the method to find neutron, that is the nucleon number equal to proton number plus neutron number. Nucleon number is 12, protons are 6 plus neutron, and neutrons are 12 minus 6, and neutrons are 6. So we can say that, and we have found out that protons are 6, electrons are 6, and neutrons are 6. And next I will try to find out which period number, which group number it belongs to, I mean the carbon belongs to. So the carbon belongs to period number 2. So if you look at the periodic table, you can find the carbon in the period number 2, and the group number, if you look at the periodic table, you can find the carbon belongs to group number 4. So the first priority will be given to the period number, and the period number tells us the number of shells. So if I draw the nucleus, there are proton and neutrons in the nucleus. You know it very well. Protons are 6 and neutrons are 6 in case of carbon. The period number is 2. Period number tells us the number of shells. So the first priority will be given to the period number, and it tells us that it has 2 shells. So you should draw 2 shells around the nucleus of the carbon. And the second priority will be given to group number. Group number is 4. So the group number tells us the number of electrons in the last shell. So in the last shell there are 4 electrons because it belongs to group number 4, and group number tells us the number of electrons in the last shell. And then we will put electron in the first shell, and we know that the maximum number of electrons which the first shell can accommodate are the 2 electrons. So this is how we can draw the electronic configuration of carbon.